So I was saying that if you're given a function like this, you're given an equation to maximize it, the 3x1 plus 4x2. The first thing to do is to write it in standard form. And the standard of it is based on the number of what? Of the constraints that you have. You have two constraints here. There is x1 plus x2 less or equal to 450, and the other one is 2x1 plus x2 less or equal to 600. So you can add other variables as you are standardizing this function. So the standard of this 4x plus 0s1 slack variable number 1 for the first constraint plus 0s2 the slack variable 2 for the second for the second constraint. This is the standard form. So that's the first step, writing in standard form. Is that clear?
Yes, sir.
Now, even the constraints themselves will have to be written in what? In standard form. That's what that means. So they will have to be written in standard form. So the first one will be x1 plus the x2, then plus, add the standard form, plus the s1. That's the first constraint, or the first slack variable for the first constraint, plus s1 equal to, now you convert the sign to equal to what? 450, not less or equal. When you add the slack variable, it becomes less or equal. Then this one, the second one will be 2x1 plus what? x2 plus s2. You get what I mean? Okay. Yeah, equal to what? 600. This is now the standard form of the constraints. So when you're standardizing, you standardize the objective function and also the constraints. You get what I mean, eh?
Yes, sir.
When I'm done doing all that, this is basically what happened here, if you are saying. This is what was happening here when they were trying to standardize. I think you have now understood. Now, when you do that, then the first thing that you're going to do, you're going to set up the initial simplex tableau method, simplex tableau. The first tableau, you create a table. That's what you mean when you say this initial tableau. Here is a table that you create, and you should pay attention. So it has, let me just say CJ. These are called CJs. That is the contribution of the objective function. You write the objective function. It does only the coefficients, okay? There is a 3, isn't it? And the 4. Okay. And the 0 and another 0. Okay. Then for the matrix itself, you can have what you call the basic variable. So let me just have the basic variable itself. You could have the basic. This is called basic variable this side. And from the basic variable, you can have the coefficients. CB is basically a column that has the coefficients of those slack variables, the variables themselves. Then from there, you can have this body matrix that has these identities. This will be for x1, right? This is for x2. This is a coefficient for x2. This is a coefficient for s1, and this is the coefficient for s2, right? From the objective function. And then you will add another column, the B matrix, which is the matrix for the products, like the last figures that you have. These, remember the constraint has got this right-hand side, this one. That's the matrix that you're going to put. These are the steps. So the basic variables that you have in this case are which ones? there is S1 and S what? S2. These are said to be the basic variables. You've gotten what I mean? So these are called what? Basic variables. S1 and S2. Okay. Then what are the coefficients for these basic variables? What are the coefficients? From the when you look at the maximization problem that what are the coefficients? What is the coefficient for S1? It's 0, right? It's 0. That's the coefficient, this one. And also for S2, it's 0. You're following, right?
Yes, sir.
I'm teaching you how to formulate
I'm
it.
just confused with the table, the format of the table.
Yeah, I think you should be fine. This is how you formulate a simplex tableau. It's you have to use a table like this one. So this is the format of the table. This is how it comes out. So you have the CJ, the first line where you write the coefficients of the objective function, all right? Which is 3, 4, 0, and 0. Like you just get this after you have written the standard, right? Standard form of the equation. Then you write the coefficients just for the standard form. You get it, right? Then from there, you write basic variable, coefficients of the basic variable, CB. And then you write x1, x2. If it goes up to x3, you can even write x3, then s1, s2. That's after you've done that, then you can write the basic variables themselves. These slack variables, s1, s2. Get what I mean? S1 and S2. Then CB are coefficients of these basic variables. So far up to here, do you have any question? Because you need to get this one. This is the foundation of everything. If you don't get this one, then you will have problems everywhere.
Niche confused the Pasapemaika CB and basic variable. It's the same check.
It's the same line. This is the same line. This is the second line. First line,
CJ.
1. This is the second line. This is the third line. This is the fourth line. Like you put them in lines.
So the first one you put the CJ, which is the first maximization. What is
the coefficients of the objective function? The objectives, the coefficients of the objective function.
And then the basic variable.
Yes, then you put the basic variables, the SO1 and the SO2, those that you added, these.
And then the CB.
It's the coefficients of these, the coefficients of the basic variables. This is 0 and 0.
What of x1, x2, s1, s2?
These are coefficients of this. This is the coefficient for 3 here. Like, just focus on the objective function. This is 3x1, 4x1, 0x. This is basically 0 SO1, 0 SO2, S2. You get what? Prezo, mind what time I'm Oh, okay. Hello?
Hello?
Yeah, so these are just basic coefficients.
Okay.
Yeah, the function is this one. We say it is 3x1 plus, 4x2 plus 0s1 plus 0s2. See what I mean? So I'm saying these are the coefficients themselves, the numbers, you put them on top. Then there are variables, you put them down. Then you add another column for P column, which is basically the product matrix. Okay?
Okay, sir.
When you're done doing that, Then you start writing the coefficients for the constraints. For the constraints. Remember our constraints? x1 plus x2 plus s1 is equal to 400. You remember this one? This one is this
Yes.
one, this same one. So, right, what is the coefficient on x1? It's 1, right? The coefficient, yes. Yeah. Then even for s2 is 1, right?
Mm-hmm.
What is the coefficient for s1? It's 1, right?
It's 1.
Then for s2 is 0. We don't have. The coefficient for s2 is 0. Then for b, the last column, the product matrix is 450, right? Like this B column is for the product. And then you come down to this other one. This one will be 2, right? We are following this one now, the second constraint. This will be 2. This will be 1. Then for S1, what will be the coefficient?
0.
It's 0. Then for S2, it's 1. It is equal to 600, right?
Why is x1 0, then x2 1? What's the difference there?
Sorry? Why is X1?
x1 0, then x2 is 1.
At X1 is 0.
Yeah, like the coefficient for x1 on this line is 1. And then for x2, for x1 is 0. Then for x2 is 1. Why is it like that?
Are you seeing the coefficient that we are following? We are following the second coefficient, this one. 2x1 plus x2 plus s2 equals to 600. This is the coefficient the constraint we are following. The coefficients are these numbers here. They are the ones that we are choosing. So for x1 is 2, right? For x2 is 1, isn't it? Hello?
Hello?
Yeah. Then for S2, for S1 here, what is the coefficient for S1 in this function? We don't have S1 in this constraint. So that's why we put 0. Then for S2, what would be the constraint? It's 1. The coefficient is 1. There is 1 here. There is invisible 1. We don't just write 1 is. No. Get what I mean? Then it's equal to 600. Or maybe I'm not getting your question. Hello?
Okay, I get it now. So for the first line where it's equal to 450, we are using that the first function, which is x1 plus x2 plus s1 equals to 450.
That's the first constraint.
Oh, okay. So on that first constraint, we didn't have s2. That's why we had to put s2 to be 0. Okay, I get this now. I get your point.
Yeah, you need to get this one, you know.
I'm trying.
You need to get this one. This one is coming. Yeah. Okay. So when you're done doing that, okay, then you introduce another column. Okay, just near the basics. This one, my SO1 is something. You will put a Z. It is called the ZJ column, the row. ZJ row. ZJ row. You know how we find coefficients here? Listen.
No.
It's basically you multiply CB. It is given by CB times these coefficients like x1 plus another CB times the x1, then you have 1. So for example, look at this. you will say, what is our CB for the first slack one? Let me remove them. These numbers can be confusing. Yeah. So the coefficients here for S1, we are in this row, is 0, right? So it's 0 times 1, which is 0, right? 0 times 1 is 0. Yeah?
Yes.
Plus 0 times 2, the second one, this row. You start from the S1, then you come down. It's 0 as well, right? Then 0 plus 0, it gives us 0. So you write 0. So that's the ZJ line. Then you go on to the next one again. 0 times 1, 0. Plus 0 times 1, 0. Yeah. That's ZJ row. Again, 0 times 1 plus 0 times 0 is 0, right? 0 times 0, 0 plus 0 times 1 is 0, right? Yes, also on the B's column here, you have 0 times 450, 0 plus 0 times 600 is 0. So you're done with the ZJ column. Then you have the last column, which is the C. CJ minus ZJ. What was the question? At one boss.
Because it's is it ZJ, something like that.
Yes.
The formula.
All right. I say is this coefficient, this one, times this plus this times that. Malemba ndiye. Again, this times that plus this times that. Malemba ndiye. Again, that times that plus this times that. Malemba ndiye. You got it?
Times 1 is so here it was like 0 times 1, 0, then plus 0 times 2, 0. That's the first 0 here. And then the second one was like 1 times 1, that's 1.
0, 0, you always start from here. 0 times 1 plus 0 times 1, 0.
So you're multiplying this 0 parallels and coefficient area.
Yes, these two will be used to multiply all these going to the right.
Oh. So it's like 0 times 1 plus 0 times plus 0 times 2. And then the second one will be like 0 times 1 plus 0 times 1, 0. Okay.
Yeah.
Then the second will be like 0 times 1 plus 0 times 0. Oh, okay.
Don't worry, you'll be fine. Then we introduce another column called C minus ZJ. CJ minus ZJ column. This one is CJ minus ZJ. So this will give us 3, right? It will be 3 minus 0, 3. 4 minus 0, 4.
ZJ
0 minus 0. And 0 minus 0, 0.
Oh, okay. So 3 minus 0, 3. 4 minus 0, 4, 0 minus, okay.
So that's that. So now, so far as it stands with this simplex tableau, the interpretation is that the value of S1 is what? Is this product, this right hand side here, is the S1 is equal to 450. Then S2 is equal to what? To 600 plus the X1 and X2. These are what? These are zeros. Okay, we haven't found them. So it means X1 x2, they are all equal to 0. Are you seeing now the issue? So the issue is that since we are maximizing the function, this is not, it can't really be dependent, because if you put zeros in this function, the objective function, you've seen it, right? Imagine you put 0. When you put these figures here, 3 times the x1 is 0, plus 4 times the x2 0, plus 0 times the s1, the whole function will just decline to 0. You understand that, right? And that is not maximizing the function. It means, guys, that if it's profit, then the total profit is 0. Then can we say that is the maximum profit? No, right? So then we know that, okay, we have found these solutions, but they are not the best solution. So what you need now to examine whether these are best solution, you listen carefully so that you don't forget. Please, when you come here, you say, you have to look at the C minus J column and look for the most positive number, the most positive. And we just have 3, 4, right? These are the only figures we have, isn't it? In this last one. You're following?
Yes, sir. But I got lost because Makambati C1 will equal to 450 and S1 will equal to 450, then S2 will equal to 600.
I was saying, if you want to report the values now, what will be the value of S1? S1 is equal to this one, the right hand side. S2 is equal to this one. Then the value of Z, which means this entire function, when you substitute, the Z will be equal to 0. Which means the objective function, the total profit, if it's profit, it will be equal to 0. That is not maximizing the function. Then X1 and X2, since they are not given, it means they are zeros. You get what, in this case. So these are not really reliable solutions as it stands at this point. In short, there is still room for you to maximize the profit. You get that, right? There is still something that you can do to improve the function so that you can get the better profit. So now, for you to know what can you do, you have to come to the C minus J column and look for the most positive number. And what is the most positive number?
3 and 4.
One, just choose one. The most.
4.
Yeah, so the most positive, the bigger one, short, is 4. All right. Now this line, where 4 lies, is column is said to be. Hello?
Hello?
I'm saying this column where 4 is said to be a pivot column, is a key column, in other words. Because this one is a column. It's said to be a pivot column. All right? So we are looking for the values of X. So what we are going to do here, Lizzie, what coefficients do we have for these constraints here? We just have only 2 coefficients, right? Just these. These are the coefficients for the constraint. The coefficients here is 0 and 1. So these coefficients will divide into this and divide into this. Then we choose the smallest positive number. You get what I mean, eh? So this will be like you divide by the constraints. Like these coefficients you get here, you divide them into this product matrix. So it will be 450 divided by 1, which will be still 450, right? In this case. Then 1 into that. If there were a 2 here, you could have said 450 divided by 2. Do you know? Once you do that, then you look for the small positive number, right? So there's 450 and 600. In this right-hand side where there is B here, what is the smallest positive number? Between the two, like we found the 400 when we divided, the 450 and 600, which one is the smallest?
450.
So it's 450. So it means that you draw, for example, a line. You may not really need to draw. Okay. We've seen what has come out. So it means that now, in this case, this one, this S1 will need to leave the row and be substituted by this variable here, the non-basic variable. Okay? Don't worry. Yeah, that's how it is when you are learning things you've never had before. Yeah, so we are saying these are steps we are building. This obviously when we repeat next time, you will be able to relate. It sounds like that. This S1 will now need to leave. That is in the second tableau because we're going to form another tableau where there is S1 here. We'll remove the S1. You get what I mean, eh? And we are going to put X2 here where there is S1. You're following, right? This X2 here, I guess you're following the steps. Don't lose the steps. These are steps. So when that happens in the second tableau, as you're going to see, when that happens, you're going to convert this number here into 1, this number here, where these two meet to 1. But lucky enough, it is already 1. You get what I mean? You have not heard. Let me repeat this slowly. In case you find that this number where these meet, this number is not 1, please make it 1. Okay?
It's a must to make it 1.
You have to make it 1. It has to be 1 always.
Okay.
When you make it 1, all the numbers below it and after it, in case there are numbers above it and numbers below it, they are supposed to be zeros. You have to make them zeros. And I'm using the word categorically make them zeros because they may not be zeros. You have to make them. And by making, there is a process of making. That's the one that I want you to pay attention. So, number 1, if you reach here, you find that it is not 1. How do you make it 1? You have to divide by itself. Imagine it were 3, maybe 3. What would you have done? You'd have divided by 3, right? Divide by 3, then it would have become 1, right? And what you have done to this number, you'd have done it along the whole row. Which means even this you would have divided by 3, this by 3, including here by 3, everywhere by the whole row you'd have done. Okay? But lucky enough, the one that we are using, there is already what? There's already 1. So there is no need of dividing. So since it is already been made a 1, what do you do next? We need to make this number here below it 0. How can we make it? We need to apply these operations. So it means we'll have to, how can we make this number 0? Using the rows. There are just 2 rows. There is row 1 here and row 2. Row operations. How can we make this number 0? Anyway, you can say row 2. You can say row 2 minus row 1. It can still give you row 2, right? These are row operations. You have 0. You've seen, right? If you
So which rows are you
deduct, for
talking about?
example, 1 minus 1, these rows here where there is x2 and s2, those are rows, like they're going to the right. 600, this line, 600, those are rows. Okay.
Mm-hmm.
So you do 1, row 2, here is 1, right? It will be 1 minus row 1, 1, right? So 1 minus 1 is 0, right? You have not hit. I'm saying we are trying to make this row here, the number down, this number here, this pivot number, 0. How can we make it? We can say 1 minus 1, then it will give us a 0. So that is here, end up becoming 0. You get what I mean? Eh? I'm doing the operations. So let me use another method. So when you follow these rows, this is what will happen. You will do the operations. You say 1 minus 1, giving us row 2. It will be 0, right?
Mm-hmm.
Then here, what you have done to make this 0, the operation you have followed, you have to apply it across the whole row. So here you say 2 minus what? 1. You get it, right? It will give us 1. You're seeing what is happening in the second table. These are numbers that you're going to see, the numbers that will come out in the second table. And then, this one is already, this side it will be 0 minus 0 minus 1. It's negative 1, right? Then this one, 1 minus 0 is still 1. You're following, right? Including
Mm-hmm.
up to B side, and you say 600 minus 450 is 150. Have you seen that also the value of B has changed?
Mm-hmm.
So, can you look at these numbers critically? In our new table, we have these new blue numbers that have written, you're following, eh?
Mm-hmm.
And this line will be maintained, this one for x2, it will be maintained like that, the way how it has been made. So that will be the new table. Then the rest of the numbers will remain the same. Okay? Can I formulate the table for us?
Yes, I can. Then I have to do this computer recordings after we are done because
You just have to. And when you do that, then here, when you change this to x2, what will be the coefficient of x2 is 4, right? You change here where there was 0, you put 4. All right?
where is the 4 coming from?
From this coefficient, kaitifa kama coefficient ya variable ili. So this coefficient is the one that we put for x2. Okay? When you're done doing that, and I'm following step by step, that's what is interesting in the way how I'm explaining. Following step by step. Can I now put these numbers in the new table? You see them, the way how they are coming out? You can redraw the table. You need to redraw the table. You get what I mean? Eh? From the operations that I've done now, you can redraw a new table. Draw a new table. Get what I mean? Okay? So when you redraw the new table, it will have the same things like this that I'm explaining. Everything will be the same. That will be a new table. New one, not like the same one. This one, I was just using it to explain. Now, the new table will have those operations that I've done. Remember, we have done operations just up to here. We have not done operations down here for ZJ and CJ, isn't it?
Yes.
Yes. So that's what I mean. So now we are going to erase these this is in the new, this is how the new table is looking. It doesn't have these CJs yet, right? So these numbers go now, these. these that they are order. Sky we have replaced by putting new ones. Okay, this is in the new table. You have seen the way how the new table is coming out.
Yes, sir.
Everything is still the same. Only that the new table has changed everything here. We have 0, 0, 0, 1, 0, -1, 1. Okay, and 150. Let me just write them now using a red marker because you have understood this. So it will be for this first one, it was this 0? Yes, it was 1. Right? We found 1. Then for the next one was what? Was 0. Then -1 for this. You remember the rows that we applied? This was 1. This was 1, isn't it?
Yes.
Yeah. Then when you reach here, well, let's go
But why
ahead now.
450, Sarah? Could it be? Why 450?
Yes, nothing changed with this operation. Remember when we did our operations, because this one was already 1. So the whole row remained the same. You get? Okay, we were dividing throughout by 1. So the numbers remained the same. That's why you didn't see the change. If this number was not a 1, you could have seen the change as well. Okay?
Yes, sir. This process, how man.
Don't
and
worry,
this is
you'll
just
be
one
good.
question.
This is just one. This is very easy when you just see master it. Okay, so let's start operating the ZJ column. How do you find the ZJ column?
Are we using the same formula? CJ
Yes,
minus
the same thing.
ZJ?
So it will be ZJ,
4
ZJ, 4 times Z.
4 times the. How are we doing this?
4 times the coefficients, boss.
Which
4
coefficients are we
times
putting?
the coefficients. This one, the x1, 1, 4, right? Plus 0, which is 9. The same signs that in the previous one, isn't it? Hello? Are you still there? Hello? Hello? Can you hear me? Is it my network or what? Hello?
No, I think it's your network because
Okay. So I was saying, you are repeating the same thing we were doing. You are multiplying everything in here by what you are doing. So you say 4 times 1 is 4, right? Plus 0 times 1 is 4, isn't it?
4 times 1 is 4 plus 4.
Then 4 times 1 again.
We are finding ZJ, not.
We are finding ZJ. You can't find C minus J, ZJ without finding ZJ. You have to find ZJ first column. Find first the figures for this row.
Okay, so the second one will be 4 multiplied by 1 plus 0 multiplied by 0, which will be 4.
Okay. Then the next one?
Next one will be like 4 multiplied by 1 plus 0 multiplied by -1, which will be 4.
4. The next one?
4 multiplied by 0 plus 0 multiplied by 1, which will be 0.
Okay. Then the last one in the B column, the B column.
It will be 0 multiplied by 150. Okay, moment.
Repeat
How
the
to
same
say
thing
it?
you did.
I've forgotten.
4 times 450 plus 0 times 150. That's what I'm saying. That's what you are doing, isn't it?
Okay. Even now could be column, we do the same. So 4 multiplied by 450 plus 0 multiplied by 150, which will be
It's 1/8.
which will be 450 by 450 by 4, which
By
will be
4.
18.
Okay.
That's our gauge.
We are almost done. So from here, Ian, is there any question?
No, from here, I just got confused. But most panga to my column kati. This one has to be one. If this was what,
I think you just have to follow the recording. Listen again. All right. So you have to say now CJ minus ZJ. 3 minus 4 to give us -1, right? 4 minus
yes.
4, 0. 0 minus 4 is -4 again. 0 minus 0, 0, like that.
And then from the big column, you're not putting anything? Okay.
So when we reach, every time we reach on CJ minus ZJ, this is a decisive decision. You have to check again. Can we further do another tableau? Can we further improve this function or not? Or this equation? But when you reach here, what helps us to improve the function, to know whether we are furthering, we can further improve or not, is the presence of the most positive number. Since we are maximizing, do we have the most positive number in the CJ minus ZJ? There we had 4, right?
Yes. And here we don't have one of 1, which is not the most.
This is not 1. This is -1.
Oh, -1. So we don't have.
So since there is no positive number, it means that the solution can never, the function can no longer, can't be improved further. Okay? It cannot be improved further. You get what I mean, eh?
Yes.
Since it can't be improved further, then it means that you get these variables. Eh? It can't be improved further, which means you can't do anything more to improve the system, you know? Yeah, there is nothing more that you can do to improve productivity or to improve the profit. You have done everything possible, okay? So you get these figures. What is the value of x1? You come again. This will be your x2. X2 is equal to what? 450, huh? I told you how to pick the answers. You just pick this x2, go to the B column and get the corresponding value. Then for S2 is what?
150.
It's 150. Then the Z function, which is the objective, the maximum profit, is 1.8. Come in the ZJ function, that's where we find the Z function, this one. It's 1.8. So what variable have you remained with? It's x1. So x1 has not been found, it's 0 in this case. Got it, eh?
Yes.
So these are your solutions, like these are the values that you're going to report. These are your optimal solutions. So the value of x2 will be 450. You have to produce 450.
What of S1? S1, we don't have any variable.
It is 0. It is 0. There is no x1 in the function that we have, the last tableau. Since we don't have x1 in the last tableau, then it means x1 is 0. So you can produce 0 of x1, right?
Which one, sir? Which one is the X tableau?
There is
the
no
one you're talking about?
x1 in this. There is no x1 in this tableau, madam. The tableau that we are looking at here, it just has x2 and s0 plus z column. There is no x1. So we are saying X2 will be 450, S2 will be 150, and Z, which is the maximum profit, our Z will be 180. But there is no X, right?
Yes.
So the answers, the optimal solutions that you report, it is the X2 450 units, X1 0 units, S2, which is the basic variable 150, and the maximum profit we can make is 18. In practice, you can say for you to maximize the profit, produce 0 of this product of X1 product, produce 450 units of X2, all right? And then the slack variable of 150, that is the sensitivity, then the maximum profit that you can make is 18. It's 1,800. That is the maximum profit you can make if you use it. Okay, just related to the graphical method, how we are finding. We were using those coordinates to check which one gives us the maximum profit, right? So this is what we are trying to say. Those values are these values that we are putting now. Okay? Hello?
Yes, sir.
Yeah. So that's that. So the solution has been reached. But imagine there was a most positive number again, which means again you'd have what? You'd have repeated what we did in the second step, where we were going to look, for example, this is 0 was a number. Let's say this 0 was 5, all right? If it were 5, then this could have stood again as a positive what? This one could have stood as a pivot column. Then to know which variable should leave or remain, you would have just gotten these coefficients and divide them into the what? Into this B matrix. You get what I mean, eh? When you divide these into that, the value that you find, you look for the smallest. Then that same smallest, draw a line. For example, if we had found that the smallest is 150 now in our case, the smallest is what? It's 150, right? Just one example. So since it's 150, the smallest, okay, then would have wanted to make this number here where they meet this one, 1, but it is 0. Would have done something to make it what? 1. Okay. After making this 1, apply the row operations that we did in the second step and continue like that. So it would have continued. You know, it's a process where you are repeating the same things again and again. You get, you'd have again gone back and repeat the same procedure until you find no positive number down. That's where it ends. As long as there is still a positive number, you continue going down, repeat the process. So there is nothing much. It's just the question of repeating the processes, repeating the same thing again and again. All right?
Yes,
okay. So this is what is there. This is a second feasible. This is a second feasible solution that is there, and this is what is reported also in the book. It's only that the reason why your module looks big is because everything I was saying, they were writing. If you read it now, you understand. They are writing everything that I was trying to mention. So, which makes it then